Hey guys, Space Marine 658 here. Today we're going to be talking about how to create a C++ function library. Now, of course, there are a lot of benefits with moving to C++ in general, but for many people who are especially newer to coding in general, or maybe you've coded before but you've never done it in C++, or maybe you've done it in C++, but you've never really dealt with Unreal Engine. So the cool thing is, by creating this function library, you can experiment, you can play around, you can get to learn the actual engine and the different pieces that you're going to need to actually code in it. So what we're going to do here is we're going to take this project and we're going to add a function library to it. We're also going to walk through the steps of creating a function, just a very simple function, something to kind of show you guys, what kind of performance benefits you can get from creating this function library, as well as some details about it. All right, so let's go ahead and get started. Now, the cool thing is, no matter what version of the engine you are using, this should work for you. Now, things might be in slightly different place depending on, of course, if you're using Unreal Engine 4 versus Unreal Engine 5 and which version of Unreal Engine 5 you're using. But this is a pretty universal concept, no matter what version of the engine you're using. So what we're going to go ahead and do is create a C++ class. Now, if you go up here to your tool section, these two bottom ones are probably going to be grayed out if you've never created a C++ class before. But otherwise, you can basically ignore them whether you have or haven't. But you're going to go ahead and hit New C++ Class. And what we're going to actually do is we're going to want to select a parent class that's going to give us some tools that we need. Now, of course, you could select none and do most of it yourself because there's only a couple of things you need to change. But we're actually just going to select a blueprint function library because what we're creating is, a function library for all intents and purposes. And so what we're going to want to call this is, I'm just going to call this a global function library, which I created before when I was doing some testing beforehand, just to make sure I understood everything. So I'll just call this my global function library. And we'll go ahead and create it. And we're going to make this, it's going to be public because you're going to be able to use it everywhere. So we'll go ahead and create a public class. Technically, you don't have to select. You could leave it, generic and unknown. I like to try to be as specific as possible when selecting public versus private, because there are times when they matter. Now let's go ahead. It's going to do a few things. It's going to try and load this up. Now, of course, this is because we're going to be able to build the engine directly within the Visual Studios that I am using. Now, of course, you don't necessarily have to use Visual Studios. You could be using Writer or any number of IDEs that are compatible with Unreal Engine. I just happen to be using Visual Studios myself. We'll go ahead and hit Reload All. And there we go. And so we'll go ahead and close that configuration. So when you get booted up, you're going to see there's basically not a whole lot in here. And that's because it's, a function library. It doesn't come with anything by default other than just a few includes here at the top. Core minimal is just basically the very bare bones stuff you need to code in Unreal Engine. And then the Kismet Blueprint function library just gives you access to a few functions within the Blueprint function library. We're not too worried about that though, because we're going to be worried about, how do we actually set up some functions so that we can use them anywhere within our game, right? So if we come back here, and let's go ahead and let me go to one of my first person player maps, one that I have. Let me go here. It's first person map. Make sure I have the right one. Yeah. So what we're going to do is I'm just going to create a super simple function, just something to kind of show you guys what it can do. So I'm going to hit edit character. And what we're going to do is we're going to remove this, and when the number 1 is hit, we're going to call that function, right? So give me 1 second. I'm going to be right back, and I'll have a function to kind of show you guys what this can do. All right. So what I've gone ahead and done is create a very simple function, nothing crazy, nothing complicated. Essentially what it does is first I grab the current time, then I'm going to iterate over a loop here where basically I've got I've got a nested for loop. That nested for loop is going through every iteration of the initial for loop and going through 0 to 1000, and it's adding those into this test var by doing a plus equals essentially. And then what I'm doing is I'm doing that 0 to 1000 times. And then once it's all done, I hit end, and then I'm basically just saying, hey, how long was that in milliseconds? So actually what we're going to do here is we're going to do two things. We're going to show it in milliseconds and we're going to show it in seconds, mostly so that way we can kind of see the true difference between the C++ implementation and our Blueprint implementation here. Now, of course, there are ways to optimize this within Blueprint itself, but this is still going to be a complex, task no matter what within Blueprints. So we're going to do get total seconds as well. So we're going to print these off. I'm going to do append, and we're only going to need one print string. We're going to do ms this, and then we're going to do that. And then we're going to put a space and then actually let's do a new line character. So if you hit shift enter, you can go to the next line. And then we're going to do seconds this, and then add a pin and plug in the total seconds. All right. So what this should get us is a kind of idea of how expensive this function is. So let's go ahead and hit start, hit 1. Now, if you're trying to copy this one for one, there we go. So it took about 3 seconds, so about 3,000 milliseconds. It'll tweak a little bit up and down, just depending on what's going on in the game engine, what's going on your computer, how strong your computer is. Lots of things can tweak this, but that's sort of roughly what we're seeing. It's 3.1 to 3.2 seconds, and so about 30. It looked like 3,200. Let me hit it again. What's that? 3,100 to 3,200 milliseconds, right? Now, if you're trying to copy this, you're probably going to get an error. It's going to say something like, you've broken your loop iterations, like infinite loop detected, the call stack. It's going to give you a whole bunch of stuff. What you can go ahead and do is go into your project settings. Now, I don't normally recommend you do this for anything except testing. Because in a game you don't want players to be sitting there chugging. You want to find those loops where you're doing way too much at once. So by setting this lower, you can find those loops a little easier. It'll just cause your game to lag out or crash while you're testing it, but you'd much rather have it happen when you're testing it than when players are testing it. So this was set to basically I added 2 zeros here to make sure it could run. Normally it's set to this, which is a relatively reasonable range. When I'm doing testing and I want to find any loops, I basically cut off 4 from the original. So from here it would be like 6. So cut it down to like 100, because depending on what I'm testing, of course, if I got something that I know is going to loop a lot, but it's relatively cheap, I might set it a little higher. But when I'm testing things where I'm not sure how many loops I'm going through, I like to set it quite low so I can catch those fast. But yeah, so I've gone through this. Now this, as you saw, was quite expensive. So let's go ahead and create a C++ version of it. How do we do that? Well, if we're thinking about it, right, this is a relatively straightforward thing. We just get the time, get the for loop. Now we could do the time thing still here inside of our blueprint, because that doesn't really eat up much, if any, performance. It's literally, setting a single variable. That's for all intents and purposes, that's super cheap to do in blueprints, because you're just hitting it once. There's no looping over these, right? So we can worry about that later. But we're going to want our function to be somewhere right here. So let's go ahead and create one. So we're going to need a for loop that's nested within another for loop, and then sets a test variable equal to something. Now, of course, we could set this specific test variable if we want to. So let's go ahead and try to do that. So what we're going to want to do is open up this, and we're going to want to create a function. All right, so I brought over a few example functions so we can kind of talk about a bunch of different things and sort of what they mean. So when you're creating a function, you've got certain key words that you're going to want to use. They're called macros, but there's also things that are within Unreal Engine here that we're going to want to look at that are important to creating this function library, right? So if we're taking a look here, I've got a few example functions. Let me zoom in a little bit so it might be a little easier to read. So you can see here, I've got this first one is called smallest angle. It's a static and it returns an F vector. So this right here, if you're new to coding, this is what it returns. And I've got the name of the function. And then within here, I've got a const vector address input vector. And then I've got a const t array F vector other vectors. So what this is basically doing is I'm passing in input vectors and other vectors, and then saying, which one has the smallest angle compared to this input vector. Now I've given it a category of custom functions and made it blueprint callable. Now, of course, that's one example. Down here, this is probably more similar to what we're going to eventually create. This is get total sum, and I'm passing in a float of n. And actually, this might be, yeah. So this is not, this is returning a float and taking a float of n and getting the total sum. And then down here, we've got this is a pure function. So there may be times when you want to have a pure function. For example, if you're getting, in this example I'm giving here, is get app version. So basically I'm getting the version of my game. The reason why I've given category of game config, I set up this way, so that way anywhere within my project, I want to just quickly get a reference to what is the project version. Is my game on version 0.0.1 or is it on 1.0.1? Whatever it is, I just want to be able to very quickly get a string reference to that. So let's go ahead and basically cut all of this down, and we're going to actually take a look at creating ourselves a function. So if we remove all this, so we got a U function. We want it to be blueprint callable. There's a few different options here as to what you can actually put in the U function. So for example, there's blueprint callable is one example, but there's other options for when you need it to be blueprint pure or so on and so forth. We're actually going to give this a category. Instead of custom functions, we're going to call this performance testing. You can put whatever you want here. This is just the category it'll show up under when you're searching for it. Which the cool thing is, means you can actually search for this and find all functions that fall under that. And this is a static float, and we're actually going to call this something slightly differently. We're just going to go and call it test function. And we're not going to worry about passing anything in because, this is just for us to hit it as hard as we can, right? We're not super worried about that. Now, as you can see here, this yellow squiggly line, this basically just means, hey, you don't have it defined anywhere, so you need to actually go create a definition. So we'll hit create definition, so it will pop into here. And what it's going to do is it's basically going to set up the most basic stuff for us. So it's going to say, hey, you're turning a float. This is your function library. Here's the actual function. And here's the definition, return 0. Because you have to have a return somewhere. And so it just gives you a default return. Now let's go ahead and save. Now what we're going to want to do is, copy that function that we already have in here. Now one thing we're going to do is normally you can go back and forth between the engine and the editor pretty seamlessly, especially when you have live coding turned on. But when you're doing a lot of changes, just to make sure you don't corrupt things or break anything, you're going to want to close down the editor just because there's a lot of things that can go wrong. So I usually recommend if you're changing things within the function, so only within here, you're perfectly fine to just do live coding. If you are changing things that are at the header level, so if you're actually adding new additional functions here and changing things at this level, you probably want to close the editor, make all your changes here, then reopen it. It does take a little bit of extra time because it takes time for your editor to reload, but it prevents you from corrupting your project by accident. Not that I've seen it happen a whole lot, and I do a lot of live building, which I shouldn't do. Do as I say, not as I do. But there are a lot of people that complain, and usually that's the source. They're like, oh yeah, I was live coding. And well, you broke something and it killed the system essentially. All right. So let's go ahead and actually create our function here. So if we want to go ahead and tweak some things, we're actually going to make this an int. I'm thinking about this. We're using int in the other function, and we want to make this as similar as possible to get as realistic of a test as possible. So let's go ahead and save these. Now, instead of returning this float here, we're going to want to do a couple things. First, we're going to need to actually initialize an int. So we'll call this int temp, and we'll initialize it with 0. If you don't initialize it, it's going to throw you an error when you try to build. So you definitely want to make sure you're initializing it somewhere. It could be initialized in the header or whatever. I'm just initializing it here because we don't actually care about this in the long run. And then we'll do for loop, and we'll say for int I equals 0. And of course, like all all for loops in Unreal Engine, you can use whatever index naming convention you prefer. I like the classic I is everything. So I equals 0, I less than or equal to 1,000, because that's what we did in the other function where we went from 0 to 1,000. And then I plus plus. From here, we're going to need to have a nested for loop. So we'll just copy and paste our for loop here, and we'll change these i's to j's. Relatively straightforward. Now, to actually match this, in the other one, we were copying the index, right? We were adding the index into that value. So we're going to do plus equals j. So what this will do is temp will continue to build up the index, and it's going to make a really massive number, and that's what's eating up the performance. And then we're going to go ahead and return temp. Not that we actually are going to use it anywhere, but you have to return something when it's not a void. Void functions technically don't need to return anything, but I don't find that I use them that often when I'm using a function library. If you're actually using voids and things like that, you're probably working in a specific like character class or something like that. So for functions, we're returning something usually. So let's make sure we got it all correct. Everything looks good here. Plus equal j. It's at 1,000, which is what the other function was. Performance testing. Okay, let's go ahead and start up our engine again. Now I do have my video editor running in the background because I made the mistake of trying to just add add 1 to that temp variable instead of add the index, and it made a very big difference on performance. So I want to show you guys a more realistic example of something that would be expensive that you'd want to do inside of C++. All right. Our engine has started up. Let's go back to our map. And what we're going to want to do is reopen our first person character here. Let's go ahead and grab the code up here for this print string statement, because of course we're basically going to want to print that same information. And then we're going to call that function. So the cool thing is we can call that function by searching for performance testing. There you go. There's our test function. That's just what we named it. And let's go ahead and print out and see what that looks like. So if we go ahead and jump back in, first we're going to retest the expensive version. Let's give it a second. So that should help there. Yeah, there we go. All right. So if we go ahead and hit 1, let's see. Yeah, so 1.8 seconds. So it's slightly faster than before, 1.18. Yeah, but we're running just shy of 2,000 milliseconds. And if we go ahead and switch back to the second function, as you can see, it's running quite fast. So just to kind of, give this a true stress test, let's go ahead and crank this up. Let's put this at 2,000 for this loop. So it'll basically double each of these loops, which in turn should have I believe, quadrupling effect on the slowdown time, or even further. Yeah, okay, so it puts us about 7 seconds, so about 7,000 milliseconds. So yeah, that had about a 4 times increase in terms of actual performance. As you can see there, that slight tweak. Now if we go to our code in here, to our function library, and let's also have this be 2000 as well. See if we can get some numbers to show up here on this side. And the cool thing is now we can hit this little button down here. This will load the live coding console, and it'll try to reload the engine. Now, of course, if you've made some changes in your code that break anything or won't rebuild correctly, it'll throw you an error. You have to go fix that and try to rebuild. But yeah, let's go ahead and see what this does. So hitting 1 again, we should see another 7-second delay, which is quite intense if you think about it for the player. Yeah. And if we hit 2, yeah, look at that. Less than a millisecond, 0.001 second. And sometimes it's going to be even lower because a lot of that depends on your CPU and what's running, what's bottlenecking, things like that. But yeah, you can see here we can run this a whole bunch of times. And that is just literally running, if we're looking just to make sure I'm not crazy, we are literally running the same code. We're saying temp plus equals the index of j. And if we go back to our blueprint code, that's basically what we're setting up here. This is our temp plus equal the index of j loop, and we're setting it. And that's how big of a difference switching it to C++ can make. Now, of course, the more expensive the function, like we showed here, the better results you're going to get. Like if we were running this and it was only like 10 iterations, right? That's something that maybe would just be perfectly fine to run in blueprints. Something you don't need to be worried about, optimizing immediately. Because look, yeah, that's running basically the same performance as 2000 within the C++ function. Yeah, switching, you might not even be able to tell. I switched back and forth between the two. That's how big of a jump that can make. But yeah. For a one-time event, it can be significantly faster, as you saw, to write the blueprint code. I guess you didn't see because I wrote off the screen. It can be faster to write the blueprint code. But once you've got the cool thing about C++ functional library is once you got it set up, it's actually really fast to just go in and be like, oh, hey, this is a function taking a lot of time. I'll go ahead and write an example function and test it out, make sure I can get the same results. Now, of course, depending on what exactly you're doing, the actual gap between the C++ function and the blueprint function are going to change. If you're doing things that are really complex, you're going to get more benefit. If you're doing things that are super duper simple, you're going to get less benefit. It just depends. But yeah, so that should be pretty much everything. If you have any questions, let me know. But otherwise, good luck and good hunting.